Sorry about that last problem got cut off. So here we have the 253.5 plus the square root of 136.89. This is 117, by the way, when you square root it. And so 117 plus the 253 comes out to, let's see, 370.5. So then multiply that times 5 times 1/3, and you get 617.5 for the volume of the frustrum. So I'm going to let you pause the video and you try, and then we'll come back and look at it together. Okay, so this next cone frustrum, we had our base 1 area is pi r squared, so that was pi times 3 squared, which comes out to 9 pi for base 1. Then for base 2, we have pi r squared again because it's a circle, so that's pi times a radius 4.5 squared, which came out to 20.25 pi. And so you plug those both into the formula, 1/3 height times b1 plus b2 plus the square root of b1 times, not plus, Miss Benton, times b2. Okay, and so that's 1/3, your height, your distance between your bases is 7.5, times your base 1 is 9 pi, your base 2 is 20.25, square root of 9 pi times 20.25 pi. Okay, so we're going to put all that in the calculator. Remember, order of operations, you need a square root first, then you need to add these two things to your third thing, and then lastly, you would multiply, right? So just keep those order of operations in mind. Okay, so we're going to, let's see, 1/3 times 7.5 times 9 pi plus 20.25 pi plus all of that square rooted comes out to 42.411. Then all of this added together is going to come out to 134.30. And then all of that multiplied comes out to approximately 335.8. All right, so I will see you guys soon. That was frustrums.
Okay, so when we last left off, we were talking about perpendicular distance. That is, we were talking about that the distance from a point to a line is always going to geometrically to be defined as the shortest distance, the perpendicular distance. We don't ever define distance from a point to a line to be that or even that. No, it's always straight down. It's always the perpendicular distance is the definition of distance. We just call it distance. And so we discovered some things. We discovered that lines are parallel when they are equidistant all the way anywhere in between them. If it's the same distance, then those lines are parallel. And then when we left off, we figured out this new postulate, the perpendicular transversal biconditional. We know biconditional now means that it is true forwards and backwards. So you could say this either way, and it does have that if and only if phrase in it. So if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. But you could also say this as if a line that's crossing two other lines, if it's perpendicular to those both lines, then those lines aren't just any old lines. They're going to be lines going the same direction. They're going to be lines that are going to be parallel. Okay, so in our U-try here, we have each tie on the railroad track is perpendicular to both of the tracks. So what is the relationship between the two tracks? Well, the relationship is the tracks are parallel. And the way that we know that is because both of the tracks are perpendicular to the same line. And if they're both perpendicular to the same line, then they have to be going the same direction. So this would be the perpendicular transversal biconditional is the name of this. So perp trans bi if you want, bicond to abbreviate. So, and then the last example we have here, find the distance between each pair of parallel lines. Well, now we know that distance is perpendicular distance, and so we know that we can just make a line that is perfectly perpendicular to both of our parallel lines, and that red line, since it's perpendicular to both, will represent our distance. And since this is vertical distance, we can just count squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is what I'm getting. So I think you try part B if you want to pause the video and come back. So the distance between these two lines, if you count across the perpendicular line, I got that to be 9 here between these two vertical lines. So what you need to do now is, hopefully you've already completed the front side of this worksheet. Number 27, part A and B here, you should be able to complete in GeoGebra now in the same strategy we used last class of plotting the point and plotting the line and finding the perpendicular distance from that point to that line. And then down here, number 28 is just a nice little word problem. You'll also notice that, let's see if I can pull it up. On Haiku, there is a nice little video of Coach Steely talking about how he uses the perpendicular lines, the perpendicular transversal biconditional to help him when he's trying to figure out how to chalk the softball field or the soccer fields. So I would highly recommend that you watch that video. Okay. Talk to you next time. Bye.